Hello, my Calc 3 student. Today we talk about triple integrals. And first I give you definition. Triple integral for some figure Q. F function is depend three variable x, y, z, dv will be limit n approach to infinity, some value your function from I to some I to n, value your function for point xi, yi, zi, z don't want to be I, times delta vi. What does mean? If you have some figure, sorry, this is writing better. If you have some object here, and we divide for some piece, but because we have three dimension, its piece will be like some cubes, small cubes here. This is this one. And we take a point for each cube and multiply it by volume for each small cubes. You see? Okay. How we work with this type of integral, I cleared there. For integrals, triple integrals, we have all identity how we have before. This means if you have triple integral for some theta, and here you have constant multiplied by function, you can take this constant out of your integral and integrate your function. You remember this is work for any kind of integrals. If you have some two function f just a moment, x okay, I try plus or minus gx dv, it will be sum or differ, depend what sign you have inside integral, two integrals. And if your region, we take region Q, we can write like some two different region Q1 and Q2 who is not intercept. Okay. This means integral Q will be, I'm write f dv, it will be shorter, sum two integrals q1 f dv plus integrals from q2 f dv. Great. But how we can count in our integrals? Okay, I'm clear here. And here we have some formulas. Okay. if your q, you can rewrite like x changing from some a to b, y changing between two functions depend only x, h1 and h2. You see, it's depend only x. And z changing between two functions depend x and y. Y. X and y. We can rewrite our triple integral f dv like integral from a to b, integral from h1 to h2, this is a, integral from f g1 to g2, f inside border how changing z, this means here we have dz, middle integral how changing y, this means here we have dy, and outside integral how changing x, this means here you have dx. How solving this integral? It's no problem, you can do it, right? Okay, see some examples. Clear there. Let's go. I have ellipsoid. For x squared plus 4y squared and plus z squared equals 16. And I need found volume this object. Because it's volume, this means I need triple integrals for q dv, right? Because ellipsoid is very symmetrical figure, this means we have something like this. And I take it 1/8 part. This means how it's work ellipsoid part in for first octant. And see how it's working. And then multiplied by 8 and I found all of them. Okay. How it's our changing our z? Our z, because we're talking about first octant, is positive, at least non-negative, until if we're solving to this equation for z, it will be square root 16 minus 4x squared minus 4y squared. Okay. How changing y? If you take it xy plane, you have, this means z equals 0. This means you have x squared plus y squared equal 4. And we have circle, radius 2. And we need to take it only part, whereas x and y both of positive. This means here it will be here. This means your y is positive and until square root for 4 minus x squared. How changing your x? X changing from 0 Now we're ready for write our integrals. This means volume will be 8, because we have 8 part. This is our x. Integral from 0 to 2. Integral from 0 to square root 4 minus x squared. Integral from 0 to square root. No, you need to write 16 minus 4x squared minus 4y squared, but if you take it 4 out, it will be 2, 4 minus x squared minus y squared. And now it will be dz, dy, dx. Okay, counting this integral, we have, okay, how it will be better writing, because I need long enough. Okay, I write what we have and then let's see what happened. Maybe check, clear a little bit there. We have 8 integral from 0 to 2. This is integral from 0 to square root 4 minus x squared. Then integral dz, respect z, it will be z. If I'm plugging endpoint, it will be exactly 2 square root 4 minus x squared minus y squared. And this we have dy dx. Okay. Now I put like parentheses here. And looking what kind of integral we have here. Square root from some constant minus square our variable, and we take a derivative for this variable. Okay. I'm use table integral. This means I'm not doing any all this part. What we have here, we have this is will be 8/16, because this 2 I moved to in the front, 16. But if you use formula, we need divide by 2, integral from 0 to 2. If you want looking where I take integral, look our end of our book. We have table, long table for integrals. It will be 4 minus x squared minus y squared plus 4 minus x squared arc sine y over square root 4 minus x squared. Sorry, it's not. It's same, but I write is not perfect. So 4 minus x squared. And all this will be dx. And here we need plugging our border from 0 to square root 4 minus x squared. Okay. If we plug, we have (16 over 2), it will be 8. Integral from 0 to 2. If you plug square root here, it will be root inside root is 0. This means 0. If you plug square root here, it's cancel it. You have arcsine 1. Arcsine, okay, I write this better. 4 minus x squared sine 1. If you plug lower border, it will be all of the 0. Arcsine, oops. Arcsine 1, not c. And this is dx. How you remember arcsine 1 is will be pi over 2. This means I have 4 pi integral from 4 minus x squared dx from 0 to 2. And if you're plugging, it will be very simple integral. I think you can count in yourself. And I write only answer. It will be 64 pi over 3. You see, use this integral, we can find volume our ellipsoid. One more question, one more example. Clear all of them. Just a moment. Sorry, it takes long time. Okay. Here we have this kind of object. Our Q is point, whereas border is z equal x, y equal x plus 2, y equal x squared. And here we talk only about positive quadrant. This means first quadrant. This means x positive, y positive, and z positive. And we need found volume, this figure. Okay. Oh, first you can see, because it's all positive, this means z changing from 0 to x. Great. What about y? X, y, and what about x, right? We have parabola y equal x squared. Great. We have line y equal x plus 2. Something like this. And we need found interception point, and looks like our region here will be this part, because remember we have x and y positive. Okay, solving equation, whereas parabola intercept our line, we have x squared equal x plus 2, x squared minus x minus 2 equals 0, and this means x minus 2 x plus 1 equals 0. It means I found two interception point, 2 and negative 1. I don't know what happened with, oops, sorry. It's gonna, oh yes, now we can write. But remember, we have some region where I'm showing you like blue. This means what we have here. Y changing between, okay, maybe I write here with safe. Y changing between parabola x squared and x minus x plus 2, and x changing between 0 and 2. Okay. Now we write all interval changing. This means I can write my integrals. Okay, I clear all of there. This means volume, or our triple integrals, volume q dv, will be integral x change from 0 to 2, 0 to 2, y change from x squared to x plus 2, z change from 0 to x, dz, dy, dx equal, okay, take it integral for z. This means we have 0 to x squared x plus 2. It will be z when we need plugging 0 and x, dy dx. It will be integral from 0 to 2 x squared x plus 2. Here we have x dy dx equal integral from x respect y. You have xy. This means here we have integral from 0 to 2 xy, whereas y is from x squared to x plus 2. And now dx, we have integral from 0 to 2 x times x plus 2. Oops. Minus x squared dx, or will be integral from 0 to x squared plus 2x minus x cubed dx. And here we count, and it will be x cubed over 3 plus x squared minus x4 over 4, 0, 2. We plug in 2, we have 8 thirds plus 4, 16 over 4, it will be 4 minus 4. This means here we have 8 thirds. Okay, now question. We always need to write order dz, dy, dx. And what is changing if you have different orders? Look in some example. First I clear my table and see some example. Okay. Just a moment. Okay. Oop. Let's go. We have this kind of integral. Triple integral q x y z x y z dv. And about q we know it says all point x y z, who is x changing from 0 to 2, x change from 0 to y change between x square and 4, y stay between x square and 4, and z change between 0 and 2 minus x. Okay. How we can rewrite this integral and how we can change order to integration? Well, first, it's very simple. Write this integral. I'm not counting every time. I write like I. It will be integral from 0 to 2 from x squared to 4 and from 0 to 2 minus x, x, y, z. Here as function we can write any order, but inside integral it's show as dz, middle it's dy, and outside is dx. Okay, how I can switch order? For example, I'm easy switch order y and z because border function for y depend only x and border function for z depend only x. This means same integral I you can rewrite like x changing from 0 to 2. Here is 0 to 2 minus x, x squared to 4, x, y, z. Now is dy, dz, and dx. Okay, and both of it's all same integral. How we can change in different changing? Okay, this is I'm clear a little bit. For this example, it's not so important, but sometimes take it integral from one function is easier for respect one variable than another. And what if we use this fact? We can change order. Okay, for example, I want change order and see how it's x and y. Okay, and I'm right y will be a last one. This means for y I found numbers borders. For x it's maybe its function depend y. Looking for plane xy plane, what we have? Y is parabola, y equal x squared. Oops, sorry, parabola. Looks like sometimes it's this way, and y equal 4. Okay. What is region we have here? Because x changing from 0 to 2, I use blue one, it will be here. Okay. Now we write different order. This means y changing from 0 to 4, y change from 0 to 4, but x change from 0 to our parabola curve, right? How we can write this one? This means x changing from 0 to square root of y. Square root of y. Because y equal x squared, this means x equals square root of y. No, for this part, I think we talk only about this positive part. Okay, and now my integral, we can rewrite like zero to 4 is how changing y. 0 to square root of y, how changing x. For z we save 0 to 2 minus x. It will be x, y, z, dz, z, x, and z, y. You see? You can continue doing, for example, I switch z and x and I try write this how it will be. Z, it will be final variable. Then we write, maybe I use red one. XZ plane. XZ plane. And here we have line. Remember, z is 2 minus x. This means this kind of plane, right? This is 2, this is 2, and this is our region. How it's changing z here? Z change from 0 to 2. Z change from 0 to. How it's change x? From 0 until this line. X change from 0 until this line z equal to minus x. Line is z equal to minus x. If we switch x and z, it will be 2 minus z. This means it's changing from 2 minus z. And now my integral, I can rewrite like z change from 0 to 2. Here is x and y, write one order you want. For example, next will be x from 0 to minus z. Y will be from just a moment, y from x squared to 4 x, y, z. First one is y, this means dy. Next one dx, and last one is dz. See, you continue as possible, all possible situation, but I think you understood how it's work. This is very simple example because, and for us it's no big deal what order we have, because our function x, y, z, we can integrate any orders, but sometimes it's important. Okay, bye for today. I think it's enough for today. Bye. Have a good day.